Hello everyone, I Himani Vishwakarma and this is my fifth video series of data science, and in this lecture series we learn about model evaluation in data science. What is model evaluation? Model evaluation is an integral part of the model development process. It helps to find the best model that represent our data and how well the chosen model will work in the future. Evaluating model performance with the data used for training is not acceptable in data science because it can easily generate our optimized and our fitted models. There are two methods of evaluating data in data science are holdout and cross validation. To avoid overfitting, both methods uses a test set non-seen by the model to evaluate model performance. What is holdout? In this method, the most largest data set is randomly divided into three subsets. First, training set is a subset of the data set used to build predictive models. Validation set is a subset of the data set used to assess the performance of model built in the training phase. Each provides a test platform for fine tuning model parameters and selecting the best performance model. Not all model algorithm needs a validation set. Third, test set or unseen example is a subset of the data set to assess the likely future performance of a model. If a model fit to the training set much better that it fits the test sets, our fitting is probably that causes. Crossing validations. This is the second crossing validations. When only a limited amount of data is available to achieve an unbiased estimated of the model performance, we use k-fold cross validation. The k-fold cross validations, we divide the data into k subsets of equal sizes. We build model k times each time leaving out one of the subset from training and use it as the test set. If k equals the sample size, this is called leave one out. Model evaluation can be divided into two sections. Like model evaluation is also divided into two sections, classification evaluation and regression evaluation. Classification evaluation. In the classification evaluation, confusion matrix. A confusion matrix shows the number of correct and incorrect predictions made by the classification model compared to the actual outcomes target value in the data. The metric is n into n, where n is the number of target value classes performing of such model is commonly evaluated using the data in the matrix. The following table display a 2 into 2 confusion matrix for two classes, positive and negative. Gain and lift charts. Gain or lift is a measure of the effectiveness of a classification model, calculating as the ratio between the result obtained with the model without a model. Gain and lift chart are visible aids for evaluating performance of classification model. However, in contrast to the confusion matrix that evaluate model on the whole population, gain or lift chart evaluate model performance in a portions of the data. This is the graph where we use gain and lift chart. The red line shows the random, this curved blue line shows the model, and this green line shows the valuations. And this is x-axis which show the properties and y-axis which show the target, which is in percentage. Lift chart. The lift chart show how much more likely we are to receive positive response than if we contact a random sample of customer. For example, by contracting only 10% of customer based on the predictive model, we will reach 3 times as many responded as we use no model. In this graph, we looked at this green line and this red, which show this is the y-axis and this is x-axis. X-axis show the population and y-axis show the lift. KS chart. KS or column grove Simron chart measure performance of classification model. More accurately, KS is a measure of the degree of separation between the positive and negative distributions. The KS is 100 if the score partially the population into two separate groups, in which one group contain all the positive and the other all the negative. On the other hand, if the model cannot differentiate it between positive and negative, then it is as if the model selected case random for the population. The case would be 0. In most classification model, the case will fall between 0 and 100, and that the higher the value, the better the model. It is separated the positive from negative cases. Thank you.